So this is a video to go along with page 7 in your notes right now. And at the top, you can see that we're going to now be moving from numerical expressions to algebraic expressions. What that means is we're basically going to be dealing with variables now at this point. Now we're going to be using the order of operations with certain formulas that you might have seen so far in some of your geometry units. Now, what type of expressions are formulas? Well, they're algebraic expressions because we have both numbers and variables. So some formulas that you might have seen before. We're going to start out here with the area of a triangle formula, and it's 1/2 base times height. And I want to point out that because we have a number 1/2 and the base times height, that the 1/2 BH, that this is an algebraic expression. And so you might have seen before in elementary school the question, what is the area of a triangle that has a base length of 8 and a height of 4? Now, depending on what triangle you see, some of you see a base length of 8 and a height of 4 in a right triangle. Others of you might visualize this type of triangle, an acute triangle, where the base is 8 and the height is 4. It doesn't matter. We're going to get the same area when we plug it into the expression 1/2 base times height. So if you see in our new unit this question, simplify the expression 1/2 base times height when b equals 8 and h equals 4, it's just telling you what to plug in for b and what to plug in for h. So it's the same as seeing a formula question from elementary school. So I wanted to remind you guys that you have seen this stuff before. You have seen letters and you have seen values for the letters and you've plugged them in. And right here, if the base is 8 and the height is 4, you could do 8 times 4 and get 32. Now cut it in half. Or you could use 1/2 of 8, which is 4, and then times 4, and we're going to get a 16 for this one. So the area of this triangle would be 16 square units. And in our new unit that we're talking about, you're going to be simplifying an algebraic expression, and you're just plugging in a letter and simplifying. And right there, our total answer here would be 16. All right, you've also seen a circle question before where you've been asked what's the area of a circle with a radius of 4. So this is one circle with a radius of 4. Or you might see a circle that has a diameter of 8. And you might remember from elementary school that the diameter is simply twice the radius. So both of these pictures show the same thing. Again, this picture also shows that half of it, that would be a 4. And so over here, if you extended it, the 4 and the 4, the diameter would be 8. So both of these pictures are actually of the same circle. Now, what we might ask you in elementary school is to find the area if the radius is 4. So you're using the 4 and you're plugging it in. And you guys know to do 4 times 4 and then times pi. So this school year, here's how the problem's going to look. It's not necessarily going to be an area of a circle problem. It might just say simplify the expression a equals pi r squared when r equals 5. So in this situation, if we plug in a 5 for the radius, 5 times 5 is going to happen first. 5 times 5 is 25, and then we get times 3.14. And so what we're saying, folks, is that in elementary school, when you've done some of the math for an area problem, right here you simplified a numerical expression. And you knew to do the exponent first using PEMDAS, 5 times 5 is 25, and then you multiplied by 3.14 to get the area. For the last one that you might have seen in elementary school, the volume of this is for surface area of a rectangular prism. And what we mean by surface area is that we want to cover up every single face of this rectangular prism. So to do that, first we're going to start with the bottom, a length times width. And doing 6 times 2 will cover up the bottom. And in the formula, we multiply it by 2 because there's a top and a bottom. But again, I just want to point out that in our new unit, what you're going to be seeing is simplify, and it'll give you an algebraic expression, and it'll tell you what numbers to plug in. And all you have to do is plug in the numbers for the variable, and then you're using PEMDAS to simplify. Now, once again, we have the commutative property in action. For 2 times 6 times 2, you could do 2 times 6 and get 12 and double that for the 24. I personally might just do 2 times 2 and get 4 and then times 6, and it's going to be the same thing. Over here, I think 2 times 6 is 12, and then times 3 to get the 36 is fine. Other people might choose to do 6 times 3 and get 18, and then double it over here. It doesn't matter, we're going to get a 36. And over here we got 2 times 2 is 4, times 3 is 12. And then when you add these three numbers up, you're going to get 72. So if you've ever found the surface area of a rectangular prism, you have simplified an algebraic expression after being told what numbers to plug in. So now we're going to flip over and we're going to see this less with formulas and more with just random algebraic expressions. And I'm going to start off here at the top. Take a look at problem 1. We're told that x equals a negative 6 and we want to evaluate x squared. Well, y'all, x is getting squared. We want a negative 6 to be multiplied by a negative 6 to get a 36. So when we're plugging it in here, we need to plug it in with parentheses around that 6 to show that it's a negative 6 times a negative 6. Notice here in red, if we don't use parentheses, it looks like this, which we know goes on to be a negative 36. So if x is getting squared and x is a negative 6, we want a negative 6 times a negative 6, which means we need to put it in parentheses. Now for the next problem over here, let x equals 2, now we want to simplify or evaluate 5x. So once again, we need parentheses. When we plug in, the x is 2. So 5 times 2, we're going to now get a 10 for this answer. And notice if we don't use parentheses, it looks like the number 52 if we just put a 5, 2. So that's why it says here we always replace values inside parentheses. You must always replace the letter with a number inside parentheses. And now I'm going to walk you guys through these next 2 examples, and then you're going to try 3 and 4 on your own. All right? So for number 1, our algebraic expression is 4b minus 6c plus 3d. And we're told that b is going to be a 1.5, c is a negative 2, and d is a 6. So we've got 4 times b, so we've got 4 times 1.5, and notice I have parentheses. Then we have a minus 6, and then in parentheses the c is a negative 2. And then we have plus 3 times d, so plus 3 times 6. And now we're just going to use the order of operations to simplify this numerical expression. So you're going to be given an algebraic expression, and you're going to replace the letters with numbers, and now it becomes numerical, and you can simply use PEMDAS to simplify. In your calculators, if you want to do 4 times 1.5 to get 6, great. I'm going to go ahead and point out that this is a negative times a negative. If you write minus 6 times that negative 2 and see that it's going to be a negative 6 times negative 2, and you're thinking 6 times negative 2 is negative 12, and then you bring the negative out in front, that minus negative still turns into a plus right here. And then, of course, plus 18. Now, my eyes actually see the 12 plus the 18 to get a 30, and then plus 6 to get 36. But you could go from left to right. All right, and now we're on number 2. So for number 2 over here, we've got y is going to be a 16, z equals negative 3, and a equals negative 1. And our algebraic expression here is the square root of y plus z squared minus a. So all we're going to do now is plug in a 16 as the radicand underneath the radical. So we're going to take the square root of 16 and we're going to add it to a negative 3 that's getting squared. And then we're going to subtract a, but a is a negative 1, and when we subtract the negative, that turns into addition. But first, let's take care of the radical and the exponent. The first one from left to right, the square root of 16 is a 4, and the negative 3 times the negative 3 is a positive 9. Notice, since this plus sign was followed by a plus 9, I only have to write one of them here. And of course, when you subtract the negative, that turns into addition here. So now 4 plus 9 is where I got the 13, and then of course plus 1 is where I'm getting my answer of 14. So at this time, I'm going to have you pause the video and just try the next 2 for practice, and when you're done, you can hit play to see how you did. All right, so let's see how you did with 3 and 4, and the work is here for you. Now, for number 3 here, when there's already parentheses in the algebraic expression, that's when you might want to bust out something called a bracket. A bracket is another type of grouping symbol, and you can use that as these parentheses right here, so that when you plug in this negative 1 for the x squared and you use parentheses, it doesn't look too weird or like one of those Wi-Fi symbols even with all of those bunch of parentheses. So inside here, we have x getting squared, so negative 1 times negative 1 is positive 1, and that times 2 is 2, and now 2 plus 4 would be 6. And now we had that times -3 out front, so that's a -18. And now for number 4, we have one big grouping symbol, this radical, and underneath it, notice we already have parentheses, so that's why in my work you see these brackets here. So A is 3 minus E is a -3. So 3 minus -3, y'all, is 3 plus 3, which turns into a 6. Now that's what's going to get squared. And since plus C is just a 0, notice I didn't even write that here because the identity property of addition says I don't have to. So inside parentheses, A minus B, we get 3 minus -3. That's 3 plus 3, which is 6. And then 6 gets squared, which is 36. So our last step now is to take the square root. Remember that this acts as a grouping symbol, so you want to do everything underneath here first. So we kept simplifying this all the way until we got it to be a 36. And then when you take the square root of 36, you get 6. And that concludes your video on pages 7 and 8. Thank you.